In the second part of the problem, we are asked to write another subset of n, which is denoted as B here, whose elements are represented by I plus 2, where I belongs to n. So if we write B in set builder notation, it would be the set of all elements x such that x belongs to n, and this follows directly from the fact that B is a subset of n, so every element of B must also be an element of n. And the second condition that this arbitrary element x should satisfy is that x can be written as I plus 2, where I belongs to n. In other words, if we take this element x and subtract 2 from it, we will get a number that still belongs to n. So if we have to write the set B in roster form, we will start out by considering all the elements of n one by one, subtracting 2 from each of them, and seeing whether we still get a number that belongs to n or not. If we do, then we'll put that element into the set B. Otherwise, we'll just ignore it and move on. So the first element of n is 1. If we subtract 2 from 1, we'll get minus 1. Minus 1 does not belong to n. So 1 does not belong to B, because 1 does not satisfy this condition. 1 cannot be written as I plus 2, where I belongs to n, because I in this case would be minus 1, and minus 1 does not belong to n. Does 2 belong to B? Well, can 2 be written as I plus 2, where I belongs to n? No, because I in that case would be 0, and 0 does not belong to n. So 2 does not belong to B for that reason. What about 3? 3 can be written as I plus 2, where I belongs to n, because if we subtract 2 from 3, we get 1, and 1 belongs to n. So for that reason, 3 would be an element of B. Similarly, 4 would be an element of B, because 4 minus 2 is 2, and 2 does belong to n, so 4 belongs to n. Likewise, 5, 6, and all the numbers up to 100 would be elements of B. The number 100 can be written as I plus 2, where I is 98, and 98 does belong to n, so 100 will belong to B. So what we are doing here is, we are scanning every element of n and seeing whether it belongs to B or not. Since B is a subset of n, the elements of B can only be formed from the elements of n. So these are the only 100 candidates for putting into B. We examine each candidate number one by one, and we see if the candidate number satisfies the second condition given in this problem. The second condition says that if you subtract 2 from that candidate, you will end up with a number that also belongs to the set n. If you look at the numbers 1 and 2, if you subtract 2 from these two candidates, you'll get minus 1 and 0 respectively. Minus 1 and 0 are not elements of n, so 1 and 2 have to be dropped from consideration. But the numbers from 3 to 100 satisfy the second condition, because if you subtract 2 from any of them, you would still get a number that lies in n. So the numbers from 3 to 100 would make up the subset B.